Hello, this is Sebastian Erich from the CloudScale-Project. In this video I'm going to show you how to come from taking measurements to demand specifications in the model. Therefore, we investigate the measurements from the previous screencast as shown here in my Windows Explorer. So these are the measurements, and try to bring them into the model for our TPC-W application. More precisely, we want to specify the demand for the CPU based on our measurements. For that, we first go to the experiments view in our CloudScale toolsuite and add a new file resource by pressing the second icon here. We select the type of data source to load to be a file data source, choose Next, and choose Advanced to link to the folder of our measurements. It's in the default location of C data. We choose OK and press Finish. What we get is the location of the file data source of our measurements. The newest measurements are always shown at the bottom. We can expand the newest measurement and have a look at the experiments run of the measurement. And now we can also see the date of the measurement when it was executed. And as I now see, at the time it was the measurement from the previous screencast. I can also expand this and see that I got measurements for a method ID with method name, public static void TPC-W, TPC say hello, print hello, which is the welcome message to the user. So the instrumented method. If I double click on this entry here, I can choose between different diagrams to show the measurement results. For instance, I can select a J-FreeChart response time series. Doing so by double clicking it, I'm provided with a diagram exactly showing the measurements I just took. If I open again my browser and open the response time PDF file directly created with the CloudScale monitoring tool, I see that these two diagrams correspond to each other. So here I have the measurement data of the system now already within my CloudScale toolsuite. I can close this diagram again and again double click the taken measurement for the method, the selected method here, and now choose a J-FreeChart response time histogram. Now I get a nice histogram for my application. What I should change is the sampling rate. For instance, I can change the sampling rate for it to this value here. I can also play around with these values to get a nice abstraction for the sampling rate. So that sampling rate results in a more coarse-grained histogram, while this sampling rate results in a more fine-grained histogram. Let's go with a more coarse-grained histogram to stay with a more simple example. You read the histogram as follows, with a probability of 0.225. I got a response time for this method call of this value. We use seconds here, so this is 0.000005 seconds. This characteristic I want now to put into my model. And there's a very easy means to do that. I just right-click in the diagram, choose additional functions, and then choose copy to clipboard as double PDF, which basically copies the histogram as a stochastic expression in terms of a double PDF. So I copy that. I can now go back So I can close this window now and go back to my model. Here I can double click on this parametric resource demand, remove the value I just estimated, and now enter via Ctrl V the value of my clipboard. What I get is basically the histogram specification directly inside the model. I can now press OK and have this value now included in my model. I can rearrange this model element a bit so I get a better overview here. So we see here that the part I specified is also displayed here as a value. I now save this diagram and have again a look at my resource environment to give this value a meaning. So I go back to the Project Explorer, open my resource environment diagram, and think again about the processing rate available here. Before I entered a dummy value, basically, which is just 1. What I now could do, for instance, would be to enter the gigahertz number of the instrumented server. For that I could have a look at the server specification, so I could use the CPU frequency info command for that. I get some data. The most important data is the frequency for the CPU, which is 2.67 gigahertz. And this value actually I want now to add to my application server here. To do so, I would double click the processing rate here and enter 2.67 E plus 9 for gigahertz. So this one would now correspond to a CPU which has a gigahertz number of 2.67. Okay, I save, and now I make also the previous measurement consistent with that. So I would go back to the demand, I can double click here and just multiply that to the double PDF. So I can again use here a 2.67 E plus 9 times the previous value. In doing so, I now modeled a system with a 2.67 gigahertz CPU, and I entered the measured values for this resource demand. We now completed the ScaleDL instance with appropriate demand specifications. In the next screencast, we will use this ScaleDL instance as an input to the CloudScale analysis and conduct an analysis based on the model. Thanks for watching.